Hello, this is Nahian Alamgir, and today I'm going to be presenting my logistic regression model. The dataset I have chosen is this one related to heart disease, which has 11 features or independent variables that we will be using to predict whether or not a person might have heart disease. After opening the CSV file, the raw data will look something like this. So first of all, I have cleaned the data. There was not really much to do because there was like one or two empty cells, so I removed those rows entirely. There was one problem where the cholesterol levels were given as zeros for a lot of the patients, as we can see here. So for this, what I have done is use the if, blank, and median functions to fill the values. As we can see, a lot of the values here are 240, which is actually the median cholesterol level. Then we have dummy encoded the data. For example, for age, I have categorized into 3 types, which is from 0 to 50, 50 to 69, and 70 or above. For this dummy encoding, we have used the if and and function. So if I were to show it right here, we will use if, and as there's more than one logic, we will link to the table and use a specific row, the row for age, and this should be greater or equal to 50. Again, we also want it to be less than 70. So we close the AND function, and for true we want 1, and for false values we want 0. And then we see the entire row has been filled. Similarly, the other variables have also been dummy encoded based on various literature which have been linked in the report and explained as well. There was one specific feature, which is the max heart rate. As the max heart rate actually depends on the age, there is no specific categories for it to be split into. So I use the quartile function to split it into 4 quarters. So from 60 to 121, 121 to 140, and etc. And then I have dummy encoded it using these values, like this one. Then we have checked how many ones and zeros we have using COUNTIF. So in this dataset, there's 53% ones and 47% zeros. So which is basically 50-50, and so I have used 50-50 for both my training set and test set. And also I have maintained an 80-20 ratio for training and test set. By splitting the data for yes values and no values, and then we have used the random number generator. I have first generated a random number and then dragged it for the entire dataset, and then I have copied the values and pasted only the values so they don't keep changing again and again. Then I have just selected the top 400 for training data and top 100, and then the latter 100 for test data for both yes and no values. And then I have sorted them randomly within the training data and test data. For the logistic regression model, we will start off with 0.5 coefficient values, and then we will solve it. The linear combination will be sum product of this entire row except for the random ID we have used, sum product of this row with the coefficient values. We will lock the coefficient values and we will get the linear combination. The sigmoid transformation is basically taking the exponentials of the linear combination. So exp of linear combination value divided by 1 plus divided by 1 plus exp of, again, the linear combination. This will help us to smooth the values from 0 to 1. As we can see, this entire row will have values that are ranging from 0 to 1. For the probability, we will multiply the target value with ln of sigmoid transformation, and then we will add 1 minus the target value multiplied by ln of 1 minus the sigmoid transformation value. This will give us the probabilities, and here we have just done a summation of the probability values to get the likelihood. Now we will use the solver to optimize our probability values. We go to data, solver, and we want to optimize this. We will use evolutionary, and the constraints will be selected for the model coefficients with a range from -5 to 5. After the solver is done working on the likelihood, we will get various optimized model coefficients, as we can see here. Now we will go to our test data set, and here we will first calculate our logistic regression values using linear combination, which is again sum product of these values with, we'll go to the regression model to get our model coefficients. We'll select these except for the intercept. We will lock the values, and we will separately add the intercept value. We see the logistic regression values are here, and the probability will again be the sigmoid transformation. So exp of this value divided by 1 plus exp of this value for calculated for each row. Now we have our probability values, which will be basically squeezed to be within 1 and 0. Now let's look at the RC curve. Here we take the minimum and maximum probability from our test data that we just worked on. We use the series function to fill values. For false positive rate, we basically compare whether or not our values are within above a specific threshold, which is this cutoff value, and then we calculate how many total negative values we have, and then we use that to divide how many false positive values we have. The false positive values are basically if the test probability that we have calculated is greater or equal to this cutoff value, and our target is actually 0, or the actual heart disease condition is actually 0. So this will give us a false positive count, and all negative count is basically counting all the zeros we have used in the test data set. Similarly, we will also calculate the true positive rate, and the AUC is basically the area under the curve. We will do a summation of these values. They have been basically calculated using finding the area of trapezoids for each of these values. So we get the area under this curve. For our model validation, we will use various cutoff values and try to optimize our recall and F1 score. As this is related to heart disease, we want to have a good grasp of basically we want to have sufficient true positive values while also not getting too many false positive values. So we will basically use various cutoff values to check for recall and F1 scores, and comparing various values, I have decided that the cutoff value of 0.308 gives us a recall of 91% and F1 score of 86.26%, which is kind of optimized for these two values. Finally, we have the interpretation. In case of key positive coefficients, we see that if the ECG feature of having ST slope as flat instead of the base value we have selected, which is upsloping, it will increase the risk of having heart diseases. Similarly, exercise-induced angina will also have a significant effect in increasing the risk. In case of key negative coefficients, we have chest pain and resting BP blood pressure, stage 1, which show negative coefficients, which refers to lowering the risk of having heart diseases. And the cutoff justification has again been explained here, where we prioritize the values of recall and F1 score.